They were never banned by law. No sheriff ever knocked on a workshop door and demanded these techniques stop. What happened was quieter and more permanent. The Industrial Revolution rolled across America with steam engines and factory glue and mass-produced screws, and in a single generation it buried 7,000 years of accumulated woodworking knowledge under a mountain of cheap furniture designed to fail. Amish never went along with it. Today, in workshops scattered across Pennsylvania, Ohio, and Indiana, you can still hear the rhythmic slap of diesel belt drives turning pneumatic tools and the softer sound of hand planes whispering across white oak. There is no grid electricity in these shops. There are no particle board panels stacked in the corners. What comes out the door is furniture measured in generations, not warranty years. Every method these craftsmen still use was designed with a single question in mind: will this piece serve the great-grandchild of the person who commissioned it? The 31 techniques you are about to see are not nostalgia. They are the reason a 200-year-old highboy still stands square and tight, while a 5-year-old big-box dresser sags on its frame and sheds its drawer bottoms onto the bedroom floor. The mortise and tenon joint is the king of all wood joints, and it has earned that title across more than 7,000 years of continuous use, traceable back to Egyptian woodworking found inside the tombs of the pharaohs. The principle is brutally simple. A tongue of wood, called the tenon, is cut on the end of one piece and inserted into a matching cavity, called the mortise, cut into the receiving piece. What separates this joint from every modern fastener is the way it behaves under load. A screw loosens. A nail works its way out. A mortise and tenon, properly cut, actually tightens as weight bears down on it. Every Amish chair, every harvest table, every door frame in a hand-built farmhouse relies on this joint as its skeleton. Hand-cut dovetails are the second pillar of traditional joinery. The interlocking trapezoidal pins and tails create a geometric lock that resists the exact pulling force that destroys cheap drawers. When you yank open a poorly built drawer 500 times, the joints rack and fail. When you yank open a dovetailed drawer 500,000 times across 2 centuries, nothing happens. Each pin is cut individually with a fine-toothed dovetail saw and pared clean with a sharp chisel. You can identify quality furniture from the 1800s by pulling out a drawer and looking at the side panel. If you see hand-cut dovetails with slightly irregular spacing, you are holding the work of a master. Drawboring is one of the most clever tricks ever invented in the woodworking tradition. The craftsman drills a peg hole through the mortise, then drills a matching hole in the tenon offset by exactly 1/16 of an inch. When a tapered oak peg is driven through, it forces the offset holes into alignment and pulls the joint permanently closed. No clamps are required during assembly. The joint stays tight for centuries without a single drop of glue. Take this further with wedged through-tenons, where the tenon passes completely through the receiving piece and saw kerfs are cut into the protruding end. Wedges are driven into the kerfs, splitting the tenon inside the mortise and locking it in a way that is mechanically impossible to pull apart without destroying the wood itself. Sliding dovetails take the dovetail principle and turn it 90 degrees. A tapered dovetail track is cut into the case sides, and shelves slide into the track from the front, locking at the back. No fasteners, screws, or nails are required. The joint allows seasonal wood movement while remaining structurally bomb-proof. Half-blind dovetails serve a different purpose, hiding the pins inside the drawer front where visible joinery would mar the design. The structural strength is identical, but the front face presents a clean, unbroken surface. This was standard on every high-end chest of drawers built in the period. Bridle joints, sometimes called open mortise and tenon, are used primarily on frame construction. They expose massive glue surface area and are visible on chair backs and traditional door frames. Tongue and groove joinery allows wide plank flooring and panel construction to expand and contract freely across seasons. The tongue on one board fits into a groove cut into the next, preventing gaps from forming during humidity changes. Frame and panel doors take this same principle and apply it vertically. A solid wood panel floats inside a grooved frame, free to swell and shrink within the groove, which prevents the catastrophic splitting that plagues solid slab doors when winter dryness arrives. Breadboard ends are the hallmark of farmhouse and harvest tables. Cross-grain caps are applied to the ends of a tabletop, and elongated slots in the cap allow pegs to slide as the wood moves with the seasons. This controls warping while permitting natural movement. Rabbet joints, an L-shaped notch cut along the edge of a board, are used for cabinet backs and case construction. They lock the case square and resist racking forces, the diagonal flex that destroys cheap cabinets within years. Half-lap joints double the glue surface area compared to a butt joint. You can see them in barn timber framing across Pennsylvania, holding together structures that have stood for 2 centuries. Treenails, which are simply wooden pegs, deserve their own discussion. Green oak pegs are driven into bone-dry holes. The peg swells from absorbed moisture and locks forever, never rusting like steel fasteners and never failing from corrosion. This is the same technique that held wooden ships together across the world's oceans for 1,000 years. Dovetail battens are sliding keys inserted under tabletops to keep wide planks flat. The batten controls cupping while permitting wood movement perpendicular to its length, and you will find this exact technique beneath the surface of every shaker trestle table ever built. Wood selection begins long before the saw touches the log. Air seasoning for 1 to 2 years is the foundation of stable furniture. Lumber is stacked with stickers separating each board, stored in rafters or covered yards with free airflow and allowed to gradually reach equilibrium with the regional climate. Once installed, this wood stops moving because it has already done all its moving. Modern kiln-dried lumber is rushed through the process in days and continues to shift for years after it leaves the factory. Riving along the grain with a FROE, a heavy splitting tool driven through the log with a wooden mallet, follows the natural grain rather than cutting across the fibers. The resulting parts cannot snap along the fiber direction, which is why hand-rived chair rungs and rake teeth outlast their sawn counterparts by decades. Quartersawn lumber is cut radially into quarter wedges and then sawn into boards. It shrinks half as much as flat-sawn lumber, and it reveals the prized medullary rays that lock dimensional stability. Heartwood-only selection rejects the sapwood for outdoor and structural work, using the rot-resistant compounds found only in the inner wood of white oak, cedar, and locust. This is why a 100-year-old fence post still stands, while a modern pressure-treated replacement rots through in 8 years. Green woodworking shapes wet, freshly cut wood while it is still soft, allowing faster hand tool work and locking joints tighter as the drying wood shrinks around dry tenons. Steam bending places green wood in a steam box at 212 degrees Fahrenheit, then bends the heated stock around a curved form, creating curves no laminated board can match in pure strength. Pole lathe. Turning predates the electric lathe by 2,000 years. The workpiece spins back and forth, powered by a foot treadle connected to a springy sapling overhead, and the cutting tool engages only on the downstroke. The resulting tool marks catch light in a way no high-speed turning can replicate. Hand-plane finishing, instead of sandpaper, is one of the most underappreciated traditions. A sharp plane iron slices wood fibers cleanly, and the sheared surface reflects light better than any abraded surface, accepting stain evenly without the blotching that ruins sanded work. Cabinet scrapers, thin steel rectangles with a burnished burr edge, slice through figured grain that sandpaper would tear out, preserving the curly maple and bird's eye figure that defines premium antiques. Brace and auger drilling uses a hand-cranked brace with a tapered auger bit. The slow torque prevents tear out on the backside of the hole, because the operator feels the resistance and stops before blowout occurs. This was the standard for chair seat boring and peg holes for centuries. Horsetail and rushes, silica-rich plants gathered from stream sides, served as the final smoothing material before commercial sandpaper existed, polishing wood to a glass-like surface. Traditional Windsor chairmakers still reach for them today. Finishes are where modern furniture truly betrays itself. Hide glue, made from boiled animal hides and bones, is fully reversible with heat and moisture, allowing antique restorers to take apart a chair built in 1820 and repair it without destroying the joint. It never creeps under sustained load, the way modern polyvinyl acetate glue does. Shellac, the resin secreted by the lac bug and dissolved in denatured alcohol, is food-safe and repairable forever. You can see it on 200-year-old furniture sitting in perfect condition in museums today. French polishing takes shellac further. Artisans use a cotton pad loaded with resin and apply it in tiny circles, building microscopic layers over hours of patient work to produce the deepest glass-like finish known to the craft. Boiled linseed oil is flaxseed oil that polymerizes through oxidation, penetrating deep into the wood fibers, so the finish is in the wood, not coating the surface. Tool handles, gun stocks, and butcher blocks have worn this finish for centuries. Milk paint, made from casein protein from milk mixed with lime and earth pigments, bonds chemically to wood rather than sitting on top. It never peels because it is part of the wood surface, and it ages with patina rather than failing the way modern latex paint flakes off in sheets. Beeswax buffed over an oil-finished surface adds a final, water-resistant layer that buffs to a soft sheen. It can be renewed forever with another application. Modern furniture lasts 5 to 10 years because it is built for shipping warehouses, not great-grandchildren. Particle board absorbs moisture and crumbles. Industrial glue creeps and fails. Staples and finish nails pull free under the gentlest stress. Every technique shown here is older than the houses most Americans live in today, and every single one outlasts the warranty on factory furniture by a factor of 50 or more. The Amish kept this knowledge alive, not out of stubbornness, but because it works better than what replaced it. The 31 tricks were never banned by law. They were forgotten on purpose, because forgetting them was profitable for the people selling the replacements. Now you know what was lost, and you know it still exists, humming quietly in workshops without electricity, producing the kind of furniture your great-grandchildren will inherit and never need to replace.